Bismillahirrahmanirrahim and Assalamu alaikum. Today we will discuss a very special type of chemical bond which is called metallic bond. It is the bond between atoms in a metal. We know in ionic bond formation the transfer of electron from one atom to another atom take place. So an electrostatic force of attraction created between oppositely charged ion which form an ionic bond. In formation of covalent bond, two atoms share their valence electrons. So the nuclei of both bonded atom attract each other, attract the shared electron, and hence we say that two atoms are bonded together. Now what happens during the formation of bond when the metal atom attract each other in the metal lattice? For example, let me say that in sodium metal, sodium atoms are held together by an attractive force. Now both atoms are same, both of them have low ionization energy, but their electron affinity is low. So if one sodium atom lose their electron, the other will also lose electron, but neither of the atom has the ability to gain electron. Similarly, all the sodium atoms are metals which cannot share their valence electron. Now the question arises that from where the atoms of metal get attractive force and how this attractive force hold the atoms of metal together in a metal lattice. To explain the nature of bond in metal, a theory was introduced. The theory to explain metallic bond is called electronic pool theory or electron gas theory. According to this theory, in metal atoms are attracted each other in such a way that every atom is attracted from all sides by other atoms. Let's take the example of sodium. Now the sodium atom, which is represented in the middle, is attracted by a number of sodium atoms from all sides and from equal distance. As sodium atom is a metal and it is more electropositive, it has the tendency to lose its electron easily. In other words, we say that sodium atom have low ionization energy and that is why it loses its electron easily. During the arrangement of these atoms around a particular metal atom, small vacant spaces are created. It is just like when balls are arranged with one another like this, then there are vacant spaces created between the balls. In the same case, when the sodium atoms are considered like spherical ball, and when they are arranged around a particular atom, it produces small vacant spaces among their atoms. Each sodium atom loses electrons in the given space. So by losing electron, sodium ion is formed. The electron lost by each sodium atom is now no more attracted by only one atom, rather they move around in the whole lattice. So we say that this electron is not localized, mean that this electron, every electron is not attracted by only one atom, rather the electron lost by each sodium atom is delocalized and it is attracted by all sodium atom collectively. So as these electrons roaming about in the vacant spaces created between the arrangement of atoms, this form an electronic pool or electronic cloud in which the positive ions are submerged. So a special type of attractive force is created between mobile electrons and the metal cation, which is said to be a metallic bond. In other words, we say that the sodium ion are submerged in the electronic cloud created when electrons are lost by every atom. Such special type of attractive force is said to be a metallic bond. Now we say that due to low ionization energy, metal atoms lose their valence electron in the vacant spaces between them. These are the vacant spaces. These vacant spaces are created due to the arrangement of atom. These electrons are now free to move and are said to be delocalized electron. Remember that when we say delocalized electron, it means that they are not attracted by one or two atoms, rather they are attracted by more than two atoms. If we taking an electron of sodium atom, then this electron is no more attracted by the single sodium, rather when it move around the lattice, when it move across the lattice, it will be attracted by all sodium atom collectively. So in chemistry language we say that the electrons are now not localized, they are delocalized. The mobile electrons form a sea of electrons around the metal ions. The metal ions submerge in electronic sea, therefore an attractive force is formed. This attractive force is between mobile electron and metal ion. This special type of attractive force gives rise a metallic bond. Therefore, metallic bond can be defined as the attractive force between metal cation and the surrounded sea of electron is called a metallic bond. One thing should be kept in mind that there are different type of metal, but some metals are hard, some are soft. So the strength of metallic bond depends upon two factors: the number of electrons set free by metal atoms. Greater the number of electrons set free by metal atom in the vacant spaces, stronger will be the metallic bond. Similarly, the positive charge cation, we know that as greater number of electrons lost by the metal atom, more will be the positive charge on cation. So if the positive charge on cation increasing, then the strength of metallic bond also increases. For example, we said that the metallic bond in sodium is weaker than that of magnesium, which is in turn weaker than that of aluminium. The reason is there is only one electron in sodium, so it can lose only one electron. Magnesium lose two electrons, while aluminium can lose three electrons. So greater the electron lost by aluminium, stronger its attractive force than magnesium and sodium. That is why we say that metallic bond in sodium is weaker than that of magnesium, which is in turn weaker than aluminium. In other words, sodium is soft while aluminium is comparatively hard. So it is all about the metallic bond, the formation of metallic bond, the electronic sea theory, and some comparison of metals, the strength of metal with one another. So it is all about the topic. Thank you and have a nice day.